Hello, my name is Tian from Simon Fraser University, and today I'll be presenting the work I did with Veronika and Lawrence, titled Impact of Multi-Robot Presence and Anthropomorphism on Human Cognition and Emotion. In today's tech-driven world, robots are becoming more common, aiding us in personal, commercial, and industrial settings. These interactions, often subtle, are transforming how we relate to robots, integrating them more deeply into our daily lives. In such a society, it is important to understand whether and how even the robot's mere presence can affect us both cognitively and emotionally. To address that, let's start with a concept called social facilitation. In particular, social facilitation is a social phenomenon that entails the presence of human observer can boost one's performance for dominant and easy tasks or impede one's performance for non-dominant and hard tasks. This phenomenon is underpinned by three key theories: drive arousal theory, evaluation apprehension theory, and distraction conflict. First, drive arousal theory theorizes that it is through the moderation of arousal level that causes this effect. The presence of others increases one's arousal level, which enhances performance in the easy task that aligns with the natural dominant response, and impedes performance in the hard task that without such a dominant response. Second, the evaluation apprehension theory argues that it is people's concern about how they might appear in the eyes of others or being evaluated that affects task performance. It can either enhance or impede performance based on the perceived positivity of the evaluation. Lastly, distraction conflict is concerned with the role of cognitive conflict. The presence of others can lead to improved performance for easy tasks or decrease performance for hard tasks by introducing a conflict between focusing on the task at hand and paying attention to the observers. Given the physical similarity between robots and humans, one question to ask is, do we observe the same social facilitation phenomenon when robots are the ones around us instead of humans? Extending social facilitation to human-robot interaction, researchers explored it with the anthropomorphic robot instead of the human, and have found that the social robot can induce similar effects. However, this work only used an anthropomorphic robot and didn't study the role of anthropomorphism of the robot. Another research team further explored how varying anthropomorphic levels influence human task performance and found that the human-like robot doesn't always lead to higher arousal levels and constantly leads to the worst performance for both easy and hard tasks. However, their anthropomorphic robot, as shown in the picture, does not represent a typical humanoid robot. Additionally, it was suggested that similar to physical robots, virtual robots can also induce social facilitation. Building on this concept, King et al. Conducted an online study to explore how a robot's motion and anthropomorphism affect social facilitation, aiming to fill the research gap concerning the overlooked significance of robot motion. However, some unaddressed gaps exist in the prior studies. The anthropomorphic robot used was not representative. Moreover, while King's study examined the active robots, they were virtual. In the realm of robotics, it is crucial to know that humans' emotional responses toward physical robots can differ from those toward virtual agents. At the same time, considering the growing emergence of groups of non-anthropomorphic robots being present in public spaces and workspaces for various purposes such as delivery, cleaning, search and rescue, and so on, understanding the impact of multi-robot presence on human cognition and emotion is essential. However, there are no existing studies considering the effects of multiple non-anthropomorphic robots and their motion patterns on human cognition and emotion. Thus, to address these gaps, we conducted a within-subject study to answer the following questions. First, how does the anthropomorphism in a physically active robot? Second, how does the number of non-anthropomorphic robots? At last, how does the multi-robot motion pattern affect human task performance and emotion? To answer these questions, we run a user study with the following independent variables. For the anthropomorphism, we have the non-anthropomorphic toy robot and the anthropomorphic now robot, These two robots differ a lot in their human likeness compared to the prior study and are commercially available, representative of their respective types. Given that the anthropomorphic robot more closely resemble humans and may heighten evaluation apprehension, we hypothesize that they will elicit higher arousal levels and the feelings being judged compared to the non-anthropomorphic robot. For the number of robots, we focus on multiple non-anthropomorphic robots as we discussed earlier, since we are more likely to encounter them in the real world. We set 1 versus 4 non-anthropomorphic toy robots. Based on the prior work that showed more robots are correlated with higher arousal levels, we expect the presence of multiple robots to lead to a higher arousal level and the feeling of being judged. For the multi-robot motion patterns, we have 1 random motion and 2 pattern motions, random moods, dispersion, and torus. Similar to the number of robots, we opt for the non-anthropomorphic toy robots. Given that random moods and dispersion elicits higher arousal levels compared to random motion from the prior work, we expect the pattern motions to lead to a higher arousal level and the feeling of being judged. Moreover, according to the social facilitation, task difficulty plays a pivotal role. Therefore, for the task difficulty, we have incorporated 2 distinct levels similar to most prior studies, easy and hard. To run the study, we have the following study design. 16 participants with 12 males and 4 females were involved and engaged in 2 cognitive tasks across 7 distinct conditions. At the same time, we tracked task performance including completion time and currency, and elicited emotions including valence, arousal, dominance, and the feeling of being judged. In the study setup, as shown in the figure, participants were seated at a desk with the laptop running the study software in front of them. Throughout, they wore headsets that play white noise to reduce the effect of noise from the robots. The robots were arranged on the right side of the laptop. As the study was conducted in person, participants were in a separate room from the experimenter. This intentional spatial separation was implemented to prevent creating potential confounding variables. This is except for the human observer baseline condition, where the experimenter was sitting next to the participant. The 2 cognitive tasks we chose are word recall and modular arithmetic that used in the prior study. Word recall is to remember the words, while modular arithmetic calculates the math expression. The study procedure was as follows. Participants started by completing the consent form and a demographic survey. They then engaged in practice sections with feedback, followed by main tasks at 2 difficulty levels, after which they self-evaluated their emotional state. The study concluded with a post-study questionnaire. Let's look at the results of our first question. How do the anthropomorphism in a physically active robot affect human task performance and emotion? For task performance of word recall tasks, the hard difficulty level tasks are correlated with lower currency as expected. We did not observe statistically significant differences, but the non-anthropomorphic robot condition did lead to the highest occurrences for both easy and hard difficulties. For the self-reported perception emotion of word recall tasks, the anthropomorphic robot elicits a higher feeling of being judged compared to the non-anthropomorphic robot. For the self-reported perception emotion of modular arithmetic tasks, the anthropomorphic robot elicits a higher feeling of being judged compared to the alone condition. Overall, non-anthropomorphic robot condition had ratings closer to the alone condition than the human condition, while the anthropomorphic robot condition were closer to the human condition. The qualitative findings reveal distinct patterns in participants' perception of the robots. Perception of the non-anthropomorphic robot were largely neutral, with most participants reporting minimal awareness or feelings related to the robot's presence. The anthropomorphic robot came across as mostly negative. It is also worth noting that even though we did not have the anthropomorphic robot look directly at the participant, people still felt like the robot was staring at them. Human presence had a more pronounced impact, with some participants describing negative and some reporting positive. From the results of the anthropomorphism, we found the following study insights. First, the non-anthropomorphic robot lead to the highest occurrence, albeit non-significantly. This non-significant could be due to the selection of task difficulties and types. Various cognition tasks can have different effects on arousal levels, ultimately resulting in variations in task performance. Second, the anthropomorphic robot lead to a higher feeling of being judged compared to the non-anthropomorphic robot for what we call tasks. The qualitative feedback from participants equals the same trend. These insights reveal the complex relationship between anthropomorphism and the social facilitation effect. The second question we had was on the number of robots and how it affects human task performance and emotion. For task performance of what we call tasks, multiple robots are associated with longer completion times for easy tasks but not for hard tasks. For the self-reported perception emotion of what we call tasks, multiple robots correlated with the higher feeling of being judged. For the qualitative findings, interestingly, none of the participants reported being affected by changes in the number of robots. Here are the study insights based on our findings regarding the number of robots. Multiple non-anthropomorphic robots correlated with an increased feeling of being judged and decreased performance for what we call tasks. However, despite the findings, none of the participants reported consciously noticing the change in the number of robots. This indicates that the presence of multiple robots may have a subconsciously negative impact on participants' experience. One possible explanation for this could be due to the impact of evaluation apprehension that the heightened sense of being judged may have inhibited participants' task performance. This implies that in certain contexts, designers may want to have multiple robots move visibly within the user's field of view to draw attention and intentionally slow down their performance. For the last question, how does the multi-robot motion pattern affect human task performance and emotion? We found for task performance of what we call tasks, multi-robot with pattern motions are associated with shorter completion times for easy tasks but not for hard tasks. However, the qualitative findings show a different view. With 7 participants noting their impact, 6 had a negative perception, indicating that they noticed both patterns and found them distracting. Only 1 participant had a positive perception, describing the torus motion as calming. Several insights are found based on the result of multi-robot motion patterns. Although pattern motions correlated with increased performance in easy what we call tasks, only 1 of our participants had a positive perception of pattern motions. This indicates that the impact of pattern motions might be implicit or subconscious, affecting human task performance in a subtle way. One possible explanation could be that when observing robots moving randomly, people may be using more of their cognitive resources to try to interpret the unpredictable movements, leading to a subconscious diversion of their attention. There are some limitations to our study as well. First, other potential confounding factors exist between the anthropomorphic and non-anthropomorphic robots, such as size and motion capability, which may have affected participants' perceptions. Second, the study only examines the number of robots with non-anthropomorphic robots, whose results may not translate for anthropomorphic robots. Also, the study only explored the effects of up to 4 robots, which may not extend to real-life scenario with more robots. Finally, we only included 2 tasks in our study, but as the task itself seems to significantly affect study results, it is important to examine a wider variety of tasks in the future. In conclusion, with the growing presence of robots in daily life, understanding the impact of their presence is crucial. Our findings provide preliminary insights into how designers or users can integrate robots into our environment. Future research can delve further into these intricate interactions between humans and robots. Thank you for listening.